Okay, so good morning everyone. In this video, we will be talking about how to solve logarithmic equations and inequalities. But before that, let us recall about the properties of exponents. We have the product of powers, the quotient of powers, and the power of a power. Let's begin with the product of powers. So given the same base, you have p raised to m times p raised to n. To solve that, all you have to do is to copy the base and combine the exponents. For example, you have here x squared times x cubed. Now you have the same base, which is x in here. So all you have to do is to copy this and add the exponents 2 and 3. Now we have 2 plus 3, that is just equal to 5. So our answer is x to the fifth power, or x raised to 5. Next is we have the quotient of powers. Given the same base but with different exponent and the operation quotient, you have p raised to m divided by b raised to n, that is just equal to b raised to m minus 1. For example, you have x raised to 5 over x raised to 2. So to do that, you have to copy the base, which is x, and you subtract the exponent. So we have 5 minus 3. This gives us x squared. Take note, this can be applied only if you do have the same base. Next is we have the power of a power. Suppose you have here x squared, the quantity of x squared raised to 3. How will you answer that? Okay, so you have to copy the base, which is x, and you distribute the exponent. 2 times 3, that gives us positive 6. So simple as that. We have recalled this one since you will be applying this in solving the problems later. Now we have the laws of logarithms. This has been discussed in the other videos, but I will be bringing it up again because this is very essential. So if you do have the logarithm of a product, that's the log of a times c to the base p. This is just equal to the log of a to the base p plus the log of c to the base p. So basically, you are just expanding the logarithm. For example, you have the log of 3x to the base 2. This is just the same with having the log of 3 to the base 2. We have this one plus the log of x to the base 2, which is in here. So you just expanded the logarithm and changed the operation of multiplication to addition. Next, we have the logarithm of a quotient. If you have the log of a over c to the base b, that is just the same with the log of a to the base b minus the log of c to the base b. So for example, you have the log of 4 over 5 to the base 3. That is just the same with saying the log of the numerator, okay, the log of 4 to the base 3 from division to subtraction. And then you have here the log of 5 to the base 3. Take note, the numerator and the denominator cannot be interchanged. You should start with the numerator and then subtracted by the denominator. Next, we do have in here the log of a raised to n to the base b, that is just equal to n times the log of a to the base b. So in here, we have just moved the exponent next or beside before the log symbol. Okay, for example, we have the log of 36 to the base 5. 36 can be expressed into exponential form, which is 6 squared, because 6 times 6, that is just 36. And we have the log of 6 squared to the base 5. Applying the logarithm of a power, the exponent in here will just be placed before the log symbol, and then you just copy the rest. So we have 2 times the log of 6 to the base 5. So everything is just the same except for the exponent. It is just changed. Now its position has been changed only. Now we have the logarithm equation. What is a logarithmic equation? A logarithmic equation is an equation that contains one or more logarithms. We have in here the properties of the logarithmic equations. Suppose, or if your base is greater than 1, then the logarithmic function y is equal to the log of a to the base b is increasing for all a. This means that if your base are all positive numbers greater than 1, then if you are to plot the graph of the logarithmic function, it is increasing. To check that, you can apply that, you can input a particular logarithmic function in the Desmos graphing calculator, and the graph will be shown to you. Again, if your base is greater than 1, the graph is increasing. But on the other hand, if your base is greater than 0 but less than 1, then the logarithmic function y is equal to the log of a to the base b is decreasing for all a. This means that if the values of your b is, for example, zero point 0.5, 1 half, 0.75, or any number between 0 and 1, then your graph will be decreasing. This also means that the log of a to the base b is just equal to the log of c to the base b if and only if a is equal to c. Okay, this is the one-to-one property. If you have in here, recall kita, for the one-to-one property, if you have in here that b raised to x is just equal to b raised to y if and only if x is equal to y. Okay, now we have the strategies. What's happening to my mouse? Okay, we have the strategies to solve the logarithmic equations. Number one, it's rewriting to exponential forms. Now, we have already discussed on how to convert logarithmic to exponential form and vice versa. That can be used in solving logarithmic equations. Number two is using logarithmic properties. That's the logarithm of a product, the logarithm of a quotient, the logarithm of a power, and even the properties of the exponents. Now, third is you have to apply the one-to-one property of the logarithmic function, the one that I have told you before. This one. Okay, so if your A and C is the same, then the log of A to B is just equal to the log of C to B and vice versa. Then you could also apply the zero factor property. That is, if A times B is 0, then A is also 0 or B is 0 as well. We have an example. The log of 2x to the base of 4 is just equal to the log of 10 to the base 4. Take note that the base on the left side and on the right side is just the same. So that means we will proceed in taking out this one. So we have to take it out, take it out. Now we are left with 2x, and on the other side, we are left with positive 10. Now our aim is to get the value of x, so we can use the division property of equality. We will divide both sides by positive 2. 2x divided by 2, that is x. 10 divided by 2, that is 5. Now, after solving the logarithmic equation, you still have to check if your answer is correct. To do that, you have to copy the entire equation. We have the log of 2x to the base 4 is equal to the log of 10 to the base 4. Then, you have to replace x with its value. In this example, the value of x is 5. So, x is replaced in here by positive 5. Now, 2 times 5, that is 10. So, we have the log of 10 to the base 4, which is the same on the right side as well. Now, since the left side and the right side is equal, that means our solution is correct. Next, we have another example. The log of 16 to the base x is equal to 2. So this is in the logarithmic form. We have the log of y to the base b, which is equal to x. So to solve this one, we have to change this one, or we have to convert it into its exponential form. The b raised to x, which is equal to y. So all you have to do is to change this form into this. To do that, just get the values of your base, your x, and your y so that you won't find it difficult. Our base in here, that is x. Our x in here, that is 2. Our y in here, that is 16. So these numbers will be substituted in this form. B raised to x, which is equal to y. Our b, that is x. Our x in here, that is positive 2, our y, that is positive 16. So we have x squared is equal to 16. Now we want to move positive 16 to the left side so we can use the subtraction property of equality. We will subtract 16 to both sides. So this is what will happen. This becomes 0 and we are left with negative 16 plus x squared. And we have to change this one. We started with the one with the variable. So the first term is x squared, which is positive. The second term is negative 16. Now we can apply the factoring methods. We have to factor out x squared minus 16 to get the value of x. If you can see, our first term is a perfect square. Our second term is also a perfect square, and we have the operation subtraction, which is the same in this form. So to do that, the factor should be a plus b times a minus b. We get the factor of the first term, we get the factor of the second term. The factor of x squared is just x and x, since x times x is x squared. The factor of negative 16, okay, is just positive 4 and negative 4. Since positive 4 times negative 4 is just negative 16. You cannot use 4 times 4 since this will result to positive 16. You cannot use negative 4 times negative 4 as well, since this will still result to positive 16. So we only have x plus 4 and x minus 4. Now we will separate these two factors. We will equate this one to 0. So this is x minus 4, which is equal to 0. And this is x plus 4, which is equal to 0. Now in here, we will apply the addition property of equality. This gives us the value of x, which is positive 4. On the other hand, applying the subtraction property of equality, this gives us the value of x, which is negative 4. Now, we need to check if our answer is correct. So you write down first the original equation. We have the log of 16 to the base of x is equal to 2. Next is to change, okay, to change the value of your x. Now our x in here is positive 4, so you have here the log of 16 to the base 4, which is equal to positive 2. Now, from this form, we have to convert this into exponential form, which is b raised to x is equal to y. So our base is 4, our exponent is 2, our y is 16. So 4 squared is just 4 times 4, which is just equal to 16. And it goes the same if you will be using negative 4, since negative 4 times negative 4, that is still positive 16. Next, we have another example, the log of 2x minus 1 to the base 3, which is equal to positive 2. So this is of the form log of y to the base b, which is equal to x. We have to change this one into its exponential form. Y is equal to b raised to x. Our y, okay, that's beside the logarithm symbol, that's 2x minus 1. Our base, this is the subscript, we have 3. Our x, or the exponent, that is positive 2. Now 3 squared, that is just the same with 3 times 3, which is equal to 9. Copy on the left side, we have 2x minus 1. Again, our aim is to get the value of x so we can use the addition property of equality. We will be adding positive 1 to both sides. So 9 plus 1, that is 10. 1 minus 1, that is 0. Now we are left with 2x. So to get the value of x, we can use the division property of equality. We divide both sides by positive 2. 2x divided by 2, that's x. 10 divided by 2, that is 5. Now that we already have the value of our x, we have to check this one again. So to check, you write down the original equation. The log of 2x minus 1 to the base of 3 is just equal to 2. Next, you replace the variable x, which is with its value, which is positive 5. Now, 2 times 5, that is 10 minus 1. Okay, 10 minus 1, that is 9. So we are left with log of 9 to the base 3, which is equal to 2. Now, from this again, we change this into its exponential form, the b raised to x, which is equal to y. Our base, that's 3. our exponent or x that is 2, and we have our y that is 9. 3 squared that is just equal to 9, which is the same on the right side. Thus, our solution is correct. Next is we have in here the log of 5x to the base 5 is equal to the log of 35 to the base 5. So if you are to check it, the base on the left side and on the right side are equal. So we have to take it out. Take it out. We are left with 5x, which is equal to 35. Now, to get the value of x, we will then again use the division property of equality. We will divide both sides with positive 5. So 5x divided by 5, that's x. 35 divided by 5, that is positive 7. To check, write down again the original equation. We have the log of 5x to the base 5, which is equal to the log of 35 to the base 5. And replace x with its value. So in this case, the value of x is positive 7. Now we have 5 times 7, that is 35. If you are to check, the left side is equal to the right side. Both are of the form log of 35 to the base 5. Hence, our solution is correct. Now we have another example, the log of 12x minus 8 to the base 4, which is equal to positive 3. So this is in the logarithmic form. The log of y to the base p, which is equal to x. We need to change this into its exponential form, which is of the form y is equal to b raised to x. In here, our y is 12x minus 8, so we have it here. Our base, that's positive 4. Our x or exponent, that is positive 3. Okay, now we have 4 cubed is just equal to 64. Since 4 times 4 times 4, that is just 64. On the left side, we have 12x minus 8. Now again, our aim is to get the value of x so we can apply addition property of equality, adding both sides by positive 8. Now 8 minus 8, that is 0, so we are left with 12x. In 64 plus 8, that is positive 72. So to get the value of x and to remove 12 in here, we have used division property of equality. 12x divided by 12, that is x. 72 divided by 12, that is positive 6. Now to check again, you write down the original equation. We have the log of 12x minus 8 to the base 4, which is equal to 3. Now, x will be replaced by the value of it, which is 6. So we have 12 times 6, which is 72, minus 8, which is equal to 3. Now, the log symbol and the base will just be the same. It's consistent, so you don't have to change that one. All you have to do is to manipulate the number inside the quantity. Now, 72 minus 8, that is 64. From the logarithmic form again, we have to change it into its exponential form, which is b raised to x is equal to y. I have already explained how to convert the exponential form to logarithmic and vice versa in the other video, so you check on that. Now, our p here, or our base, that's 4. Our exponent, that is 3. Our y is 64. So 4 cubed is just equal to 64, which is basically the same on the right side. Hence, our answer is correct. Now we'll move to the property of the logarithmic inequalities. If the base is greater than 0, then if the log of x to the base b is greater than the log of y to the base b, then x is greater than y. And this will also follow if you will be using the inequalities less than, greater than or equal, or less than or equal. For example, you have here the log of x to the base b, which is less than to the log of y to the base b. This also follows that x is less than y. Or if you have in here the log of x to the base b is greater than or equal to the log of y to the base b, then it also follows that x is greater than or equal to y. Or even so, if you do have it in here, the log of x to the base b is less than or equal to the log of y to the base b, then it also follows that x is less than or equal to y. This will fall if their base is greater than 1. Say 2, 4, 5, 6, 7, 8, and so on. But on the other hand, if your base is greater than 0 but less than 1, the numbers are 0 0.5, 1 half, 0.75, 3/4, and so on. Any number that is between 0 and 1, then this is what will happen. The log of x to the base b is greater than the log of y to the base b, if x is less than y. So basically, the inequality symbol will be changed from less than to greater than, from greater than to less than if your base is greater than 0 but less than 1. Okay, let's have an example here. The log of x to the base 3 is less than 4. So to solve these, we need to equate the base should be the same on the left side and on the right side. So we have 3 in here. This becomes 3 to the log of x to the base 3 is greater than 3 to the fourth power. Now this is cancelled. We have applied the properties of the logarithm function, and then we have here that's x. We are left with x is less than 3 to the fourth power. 3 to the fourth power is just the same with 81, since 3 times 3 times 3 times 3 is just equal to 81. Now ma'am, are we gonna change the inequality symbol? No, because our base in here is 3, which is greater than 1. If it's greater than 1, then you don't have to change the inequality symbol. Next, we have the other example, the log of x to the base 4, which is greater than or equal to 5. Again, the base on the left side and on the right side should be equal. So this could be 4 to the log of x to the base 4 is greater than or equal to 4 to the fifth power. This is cancelled. Now we are left with x is greater than or equal to 4 raised to the fifth power. Now 4 to the fifth power, or simply 4 times 4 times 4 times 4 times 4 is just equal to 1024. Now ma'am, are we going to change the inequality symbol, this one? No, because again, our 4 is greater than 1. So the inequality symbol will be the same. Next, we have the log of 4x minus 8 to the base 3 is greater than or equal to the log of 2x plus 4 to the base 3. So if you are to see, the base are the same already. So we take it out. Now we are left with 4x minus 8 is greater than or equal to 2x plus 4. The next thing that you will do is to combine the like terms. So here we have combined 4x and negative 2x, since they are like terms. They have the same variable and they have the same exponent. Now, ma'am, why did this become negative 2x? From positive 2x to negative 2x. So we have simply applied the subtraction property of equality. And on the other side, we have combined both constants, which is positive 4 and positive 8. From negative 8, this becomes positive 8 since we have moved it to the other side. Look at this. 4x, that's the same. 4, that's the same because we did not change them. We didn't do anything to them. Negative 8 is moved to the other side, so this becomes positive. Positive 2x is moved to the other side, so this becomes negative 2x. Now 4x minus 2x, that's positive 2x. Copy the inequality symbol greater than or equal, and we have 4 plus 8, that is positive 12. To get the value of x, all you have to do is to divide it by 2. So we have 2x divided by 2, that is x. 12 divided by 2, that is 6. Again, we don't have to change the inequality symbol because our base is 3, which is greater than 1. You will only be changing the inequality symbol if the base is greater than 0 but less than 1. Now, to test your understanding, answer the following logarithmic equation, inequalities and equation. So number 1, you have the log of 4x to the base 5 is equal to the log of 24 to the base 5. Number 2, the log of 10x minus 9 to the base 3 is equal to 4. Number 3, the log of x to the base 6 is less than 3. Number 4, the log of 2x minus 1 to the base 2 is greater than the log of x plus 2 to the base 2. And you study about the graphing of logarithmic functions. This is a lot easier, no, because I have already given to you the properties of the logarithmic function. All you have to do is to input a logarithmic function in the Desmos graphing calculator, and the graph will be shown to you. Okay, so if you do have questions, you may write it down below, and then I will be willing to answer. Thank you so much, and goodbye.